All right, so now we're moving on to day 2 of section B, and we're still doing index laws, and we're still the exact same objectives to understand and to apply the index laws. All right, we've already gone through 4 of them. We're going to go through a couple more today, and now we're going to, in today's video, apply multiple of them together at the end. All right, so let's just go back to the index laws and look at the ones that we're going to learn today. All right, so we've already covered this one here, where a times m to the a to the m power times a to the m power is equal to a to the m plus n, where we're multiplying same bases. We add our indices or our powers. We've already talked about when we're dividing numbers with the same base, we subtract our indices or power. We learned about our power to a power rule, which is when we multiply the powers or the indices. And we've also talked about this one here, where anything raised to 0 power, as long as if it is not 0, is equal to 1. All right, the ones that we are going to focus on today are going to be these two here. All right, and what this is saying is if we have the power of a product, so in this case we have a to the b being raised to the m power, that we are essentially just going to distribute this power into both of our terms since they're being multiplied. It's only when it is the power of a product. All right, there is a mistake that I anticipate a lot of people are going to make when we move on down the year, because everyone does it every single year. But it's when we have the power of a product. So as long as if these two numbers are being multiplied together, we can distribute this power in, and it becomes a to the m power times b to the m power. All right, so if I have x times y being raised to the third power, I can distribute this and get x cubed times y cubed because they are being multiplied here. They are being multiplied. It is the power of a product. All right, but just remember, as long as if they're being multiplied, then everything gets raised to that power. All right, and then the next rule, it's pretty much the same thing as if we have two things being divided, so the power of a quotient, a over b, and is being raised to the m power. Since they're being divided here and the power of a quotient, we then go ahead and distribute this power to everything that we have. So it becomes a to the n over b to the n. All right, so as long as if they're being divided on the inside, then we can go ahead and just simply distribute. So x over y being raised to the fourth power, each of these will be raised to the fourth power, so it becomes x to the fourth over y to the fourth. All right, so those are the only two rules that we're going to go through now, and now we're going to go through some examples. All right, our first examples we're going to go through do not necessarily reflect the powers or the laws that we just went through, but it's more of a continuation from yesterday, last video. All right, so in this case here, if we have for a 3 to the x squared, so 3 to the x, 3 times x squared, being multiplied by 5 times x to the fifth, we multiply all of our likes together. So what that means is we are going to multiply our constants or coefficients together. So then we would get 3 times 5, which is 15. And now since these are the exact same variables with the same base, we can go ahead and use our power law, which is going to be we add our powers together. So it becomes 15x to the seventh power. All right, so then for section B, we are now dividing here. So same thing, we divide our likes with our likes, meaning we first look at our coefficients. So these two are our coefficients. So we say, can we simplify or divide them? Well, 4 goes into 25 times. And then we look and say, well, are these the same base? And they are. So since they're the same base, we can go ahead and apply our quotient rule that we learned, which is when we have the same base, we can subtract our powers. So it becomes 5a to the third power. All right, and then for C, the first thing that we have to do for this one is, well, there's a few things we can do first, but let me just rewrite this out. Is we have this power to a power. So I'm just going to go ahead, actually, I'll do it all together. I'm going to look at my numerator first. So here we have the exact same base, so we know our rule is we can add them together. Here we have a power to a power, so our rule is we can multiply them. So it's 2 times 4. So b, 3 plus 7 is going to give us b to the 10th. 2 times 4 is 8, so it's over b to the 8. Now we can apply our quotient rule because we're dividing and we have the exact same base. So we can then do b to the 10 minus 8, which is going to give me b squared. Right, so our final answer for that one would be b squared. So sometimes there will be multiple laws that we have to apply. Sometimes there's only going to be one. but you must just keep going and simplifying until you can't simplify anymore. So even though we got b to the 10th over b to the 8th, we could continue and use our quotient law. All right, now this is going into the laws that we just talked about earlier in this video. So we have 3 times a squared. So since we have a product and these two are being multiplied, we can go ahead and raise each of these to that second power. So we get 3 squared times a squared. Well, we know that 3 squared is equal to 9, and a squared is just going to remain a squared. I will, on your test, be very clear as to when you will need to multiply that 3 squared to that 2 squared. But if it's a number like 3 squared and you know that very quickly, then you should just keep simplifying. 11 to the 8th power in the last video, we didn't know that. So that's why also I would never expect you to actually give me that answer. All right, but this one here, it's applying 2 things that we learned. So here we have a product being raised to the power. So this 3 goes to the 2 and to the x. And then we also learn that whenever we have a quotient, we divide or we raise that power to everything in our quotient. So this then becomes 2 cubed times x cubed over y cubed. All right, so now we can keep going and keep simplifying. 2 cubed we know is equal to 8. And then we have 8x cubed over y cubed. There is nothing else that we can simplify and nothing else that we can do. So that is it. All right, we do have a lot of examples we're covering in this video because after this, I still have 2 more I want to give you guys. All right, so for this one, all of these are being, so for A, all of these are being multiplied. So when it's our product, it doesn't just necessarily mean it's 2 things. Every single one of these are being multiplied together. So that means this power 4 can go to every single one. So it becomes 3 to the 4th power times A to the 4 times 3 power because we already had a 3 and now we have a 4 times B to the 4th power. And now we just simplify as much as we can. All right, once again, I will be very clear with you in the directions, but 3 to the 4th, we already did that in one of our videos. We know that this is going to be equal to 81. 4 times 3 is 12, so it's a to the 12th power and b to the 4th. On your test or quiz, I will be very clear as if I want you to actually raising this to a power. Right? And if it's one that you can do, 3 to the 4th, I expect you all can do that, then I will expect it to be done. But if it's something like 11 to the 8th, then I'll tell you can just keep it as is. All right, here we have x squared, 2 times y. So this is exactly like the last problem we just did. This is a product, and this is a quotient. So everything is being multiplied or divided. So this can then go to every single one of our variables and coefficients. So it becomes x squared times 3, because we already had an x squared. Right? Then we get 2 cubed times y cubed. Well, we can then just go ahead and simplify this. Well, x squared times 3, this gives me x to the 6. 2 cubed is 8 and y cubed. So that will then be your final answer for this question. All right, so sometimes we will have multiple things being multiplied and not just 2 like we had in some of our other examples. And they all need to get that power as long as if they're being multiplied. If there's an addition or subtraction sign in between there, then this rule does not apply. It has to be to the product. All right, there are 2 more examples that we're going to go through. So you may see some problems like this. So now in this case, we have to remember our PEMDAS. Right? So the first thing that we need to do is our parentheses or our brackets. There's nothing that we can do inside of this parentheses, so it's done. So then the next thing that we will do is our exponents. Well, here we have a power to a power, so we need to apply that. So it becomes x squared times 4, which is then x to the 8th power. And then we can multiply what's left over because multiplication is after exponents. So now there's just a 3. There's only a 1 here, so it's going to remain 3. And now we have this x to the 8th times x to the 5th. So when we are multiplying the same base, we will then add our powers. So this will then give me 3x to the 13th power. All right, so there will be questions where there will be multiple steps that you need to do. A lot of you see, not a lot, there's a couple or a few that seem like you're still struggling with the order of operations. And if you still are, please, 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 I can give you extra worksheets to work on it because it's very important, not only throughout this year, but through the rest of your high school that you understand how to do order of operations. All right, now this question is probably the hardest one that we've seen so far in this section. All right, so same thing. We need to do our PEMDAS. Well, inside of our parentheses, there's nothing that can be done So we won't do that first. And then we go to our exponents. So that means since all of these are being multiplied and it's the product, we can distribute this 2 to all of them. And then we can distribute this 3 to all of them. So we will then get 5 squared times x squared, or x to the second power times 2, because we're distributing that in, times y to the third power times 2. And then this is all being multiplied with, we have 2 cubed times x to the third power times 3, because power to a power we multiply, times y to the fourth power times 3. Right, now I'm going to go ahead and simplify everything in my parentheses. So it becomes 25 x to the fourth power, y to the sixth power, times 8 x to the ninth power, y to the 12th power. And now since these are being multiplied, we go ahead and multiply all of our likes with our likes. So we will then do 25 times 8, which is going to give me 200. We will then do x to the fourth times x to the ninth. Since these are the exact same base, we would add them, so 4 plus 9. And then we will have y to the sixth times y to the 12th. Since they're the like base, we add them, so it becomes 6 plus 12. So this then is your final answer, 200 x to the 13th, y to the 18th power. Whoops. All right, so that is it for this video. And there's one more video and one more day for this section, and we're done with section B.